So I can now move on to my last part of the lecture. Let's do it together. Of course, first, you only know what your takeaways were, and please clarify those for you. Also, please ask yourself what didn't you understand and which parts still need clarification. But ultimately, what you need to take away from this is that everybody consists of an infinite number of extremely small particles or infinitely small particles. We understand that, right? They also have a super small weight, and they have a certain distance from the origin. That is important. You understand that. So that is what we called actually x tilde, right? That is that part. Here we call it, for example, dw or dm or dv or even dA. All that was the same. Now, you understand next that the center of gravity is the point at which all the resultant weight is balanced, or even the mass and so on. So this is the balancing point, and that is the point of checkbox number 3. And now you also understand the difference between the centroid and the center of gravity, because the centroid is actually a geometric center. So this has nothing to do with the material or anything. And because it's geometric, you can do it for a volume, for an area, or for a line element. We, of course, didn't discuss line elements, but I think everybody would be able to conclude that themselves. Last but not least, you can now mathematically solve these problems. And of course, the ultimate goal is to find the support reactions using these random shapes. So now you can solve this. And that concludes the lecture. Let's take a final look at the homework. So here you have random shapes, centroids, given in terms of function. Notice that each shape here is given with a specific function, and that you now need to find only the centroid here and here. But here, for these two problems, you are supposed to find the support reactions. Now, this problem here is slightly different from what we had as an example, because remember that when you integrate, and actually this is true here as well, so here you get to practice that. Remember that when you integrate, you always find the area under the curve, right? So here you find the area under the curve. So you have to find a trick for these two problems to integrate for such that you find the area above the curve. So if I look at that conversely down here and here, if you integrate from 0 to 3 here, you will immediately get the correct result because you integrate the shaded area. But if you, and the same is true here, by the way, of course, it's a strange integration constants, but that's because of the function. Sorry, not integration constant, but integration limits. So 0 to 2.183. But if you integrate this, you will immediately find the answer for the area, whereas for this problem and this problem, you actually, if you were blindly integrating, you will find the area under the curve, and that's not what you want in this case. And in this case, you want the area above the curve. So please pay attention to that. And that, I think, is everything I can tell you about the homework for this topic, and I wish you good luck with that, and I'll see you in the next lecture.